Welcome to another lesson on the art of programming with Python. In this lesson, you will not only understand every technical aspect of the program you wrote, but also discover how a deeper look at the tools that you used reveals key principles of the art of programming. Here is the program you wrote. Let's break it down. Get ready. You're about to learn a ton. Our program is just a single line of code that instructs the computer to perform a computation. An instruction to the computer is called a statement. In this case, the statement evaluates an expression. The numbers in our expression are values. A value is any piece of data that can be used in a computation or stored in memory. Each value has a type, which determines how it's stored in memory and manipulated. Some examples of types are an integer, like the ones in our expression, a floating point number, a customer name, an email list, or even a video. Notice how broad the concept of a value is. Similarly, an expression is anything that evaluates to a value, making it just as broad. As mentioned, we're laying a very solid and general foundation here. Now, let's take a closer look at 15 plus 10. This expression uses the plus operator applied to the values 15 and 10. These values are called the operands of the operator. The plus operator is binary because it works with two operands. There are also unary operators, like the unary minus in the expression -5, and even a ternary operator, which we'll explore later in the course. Once this expression is computed, it becomes the left operand of the second plus operator. The right operand of the second plus is a call to the pow function, which computes 2 raised to the power of 3. A function is a program that accepts values called the arguments, performs useful actions, and returns the result called the return value. In this case, we called or invoked the power function and passed 2 and 3 as arguments. Note that the arguments appear inside parentheses and are separated by a comma. Note also that the order of arguments matters. The place in the program where a function is invoked is called the call side. The function computes the return value and returns it to the call side. Please realize that we're learning principles that apply much more broadly than math functions. This is because you can write your own functions that can accept arguments and return results of types related to your application's domain. And the same principles will apply. In the shown example, an application for a sales department has a function that returns information about leads based on search criteria passed as arguments. We're now approaching a fundamental principle of the art of programming. Note that a function is like a black box. Namely, you don't know, and you don't want to know, any details about the power function's implementation. The way a function hides its implementation from its users is an example of the essential principle called encapsulation. I'm going to put this principle like this. Minimize the amount of information a reader of your program, including yourself, needs to keep in mind at any given moment. In other words, always hide unnecessary details and expose only what's relevant for working with a specific part of the program. This principle may sound simple, but it carries profound implications. If you truly internalize this principle, you'll grasp the thought process behind many language features, and your programs will stand out in quality. We'll revisit this principle throughout the course and explore how encapsulating implementation details offers benefits beyond reducing the programmer's cognitive load. For now, I want to help you internalize this principle by using the power of association. So, let's relate it to something familiar. Imagine needing to understand how a transmission works just to shift your car into drive. As you see, hiding unnecessary details from users is a universal principle. Another important point to note is that the power function is well behaved in two important ways. First, it always returns the same result when given the same arguments. In other words, its return value doesn't depend on any external state, like user input, a value stored in the memory, or in a database. Second, it has no side effects. Side effects are actions unrelated to computing the return value, such as printing to the screen, modifying a database entry, or sending an email. A function that always produces the same result for the same arguments and has no side effects is called pure. The power function is pure. We'll explore the benefits of purity later in the course when we learn to write our own functions. Now, on to the last technical detail, the outer parentheses. We need those because without them, multiplication would take place before addition. In other words, the multiplication operator has higher precedence than the addition operator. The parentheses explicitly specify the order of computation, ensuring that the expression inside them is evaluated first and becomes the left operand for the multiplication. Congratulations! Not only do you now have every term needed to describe the technical aspects of our first program, but you also took a peek behind the curtains to uncover some foundational principles of programming, revealed through a tool that many less fortunate programmers mistakenly consider boring.